Hello, we are Team Cool Vials, including Jenna,
Sam,
Skyla,
Olivia,
Ariman.
Our problem statement includes the following.
Researchers at the Marcus Center for Cellular Cures at the Duke University Medical Center use stem cells to treat multiple sclerosis, cerebral palsy, and other conditions. They need a container to hold vials of stem cells at a temperature between 2 and 8 degrees Celsius for at least 30 minutes.
Now I will begin a discussion of our design criteria. Our first design criteria, temperature maintenance, was the most important, making it a constraint. The vials must be kept between 2 and 8 degrees Celsius for 30 minutes. In order to satisfy this design criteria, we designed a cooling mechanism. This involves a thermally conductive material, which we chose to be aluminum, in the form of an inner wedge, as seen here. It also involves an insulating material, which we chose to be polyurethane foam, surrounding the container and as part of this lid. There are also cooling gel packs lodged between the wedge and insulation to facilitate cooling.
For testing cooling, we had 12 trials, measuring the temperature of the middle of the holes and the surface of the container, both with and without gel packs on the sides of the wedge. And in each case, it stayed between 2 and 8 degrees Celsius for 30 minutes, the highest temperature it ever got being 7.1 degrees. As a result, we found that the design can work even without ice packs, giving our client a choice of whether they want to use these packs.
The second design constraint is the ability to hold the vials. Our device had to hold at least 10 vials and had to accommodate all sizes used in the Marcus Center, including the 20, 10, and 6 ml vials used. In order to satisfy this design criteria, 11 holes with a 1.16 inch diameter were drilled into the wedge, with depths varying from 1.03 inches to 1.5 inches.
For testing the ability to hold the vials, we had our client take the vials in and out of the holes, and our client found that the 6 and 10 milliliter vials fit, but the 20 milliliter vials could not fit due to the labels being on the side of the vial. As a result, we widened our holes and tested again, and the holes now fit all 3 size vials.
The third design criteria was ease of use. This means that the device must be easily transported and manipulated for research purposes. To accomplish this, we added grips to the bottom of the container so that it can easily be lifted and carried. We also added an acrylic wall to keep cool air from leaving through the front of the container, but we made this wall removable so that researchers could easily access and remove the vials if necessary.
For testing ease of use, we gave our client 2 other professionals and 2 non-professionals a survey, asking them to rate aspects such as the ability to carry the container and the ability to put the container together and take apart, from 1 to 5. For every aspect, our goal was to have an average score of 3.5, and we indeed got an average score at or above 3.5 for every aspect.
Another objective of ours was to mitigate condensation. We designed our solution to require wiping less frequently than once per hour. The vial holder has a 30-degree slope so that all condensation flows off of it into a basin filled with sterile sponges. We determined that we met this requirement as there was negligible condensation to begin with, and the condensation that did form flowed into the basin. Strength was also a concern of ours. So, we designed our outer box to hold more than 5 pounds by using strong, durable materials. We also fastened L brackets on the exterior of the box in order to prevent the sides from collapsing inward.
For testing strength, we picked up the design, moved it around and put it back down. We conducted this process 100 times, and though it passed 98 times, there was a problem when we tilted the design because the front portion was not strong enough to hold the aluminum block in place, and therefore it broke. However, we added metallic braces to strengthen that portion and conducted the same test 100 times additionally, and it did not fail this time around.
Of course, safety was also an objective. In order to comply with both our clients and the hospital's standards, only sterilizable and durable materials, such as acrylic, aluminum, and polyurethane were used.
For testing safety, we verified that the outer polyurethane foam that we were using can be wiped down with ethanol wipes, and the design does not contain any dangerous components that could pose any kind of threat. We calculated the cost of all external resources used to design the project. The total was $80, which is well below the $350 budget given by the client.
In conclusion, our device keeps vials between 2 and 8 degrees Celsius for 30 minutes, fits the appropriate vial sizes, and provides a solution to the problem of condensation buildup on the surface of the container. For absolute completion of our design, we would like to add an electric instantaneous temperature reader and use higher fidelity junction materials.